Hi there and welcome to a new video of me, Jonas, showing you quantum computing, quantum sensing and quantum communication companies that are out there in the world. Today, in this video, we are looking at Quantinuum, which is another company in the space of quantum computing. Before we start the video, make sure you get something to drink, always stay hydrated. And let's dive right into it. So here we are at the website of Quantinuum. It says, pioneering the next era of computing. As the world's largest integrated quantum computing company, Quantinuum is leading the development of the most powerful quantum computers and the most advanced quantum software solutions. So again, looks like what we're having here is a fully integrated company. So basically all the way from hardware, so creating something that can execute that can create confined quantum systems that serve as qubits, all the way to providing solutions for real-world problems, or potentially providing solutions for real-world problems. Let's also quickly take a look at this. So that looks a little bit different from the superconducting ones that we saw before. Here we can see that there is like windows potentially in a vacuum chamber. So I would assume just from looking at it, we're talking about something more in the optical vacuum, so ion trap, atom space here in this case. Let's scroll down and see what we have here. Solve tomorrow's challenges with our technology today. Quantum hardware. So the world's leading quantum computers powered by Honeywell. Interesting. So here we see the quantum computers themselves, they're provided by Honeywell. Then it says computational chemistry, enabling the next generations of complex molecular and material simulations. So this is basically a problem that they are solving, or that they are aiming to solve. So in the materials and molecular space. So using quantum computers to simulate quantum materials, that makes sense. And we also have cybersecurity, so that goes all the way to Shor's algorithm, I guess. It says the only provable and software development quantum random number generator. Interesting. So this is not about hacking or decrypting RSA keys. It's really about using a quantum system to generate a random number, which is also a very interesting problem in itself. Probably worth a whole discussion in itself. Uncover the unique advantages of our integrated full stack. So they also have the aim to do a full stack here. Our best-in-class quantum computer software and developer toolkits are designed to work seamlessly. This enables our users to drive breakthroughs in material discovery, biology, cybersecurity, and next-gen quantum AI, and more. So how does it look like? We don't know yet. But here we see that Honeywell is already apparently working with this. They say by incorporating quantum origin into our products, we enhance the security. Okay, so this is very much focused towards the security. Then we see JP Morgan Chase, which is a big bank. I think the biggest bank in the US, right? They also say here it looks like they are using those systems. Then we have Thales, which is a European company, I think French originally. Also a big technology company that is using this. And then we have BMW, which is a German car manufacturer, so also a European company, which is using this in the space of mobility. Okay, interesting. Then it says science-led, enterprise-driven. Our visionary approach requires individuals who are committed to pushing the boundaries of what's possible. In Quantinuum, you will find pioneering scientists who are dedicated to uncovering new and exciting applications for quantum computing in the real world. So now here we can learn a little bit about the team. The team includes 375 plus people with PhDs and master degrees. So very interesting. 155 publications already, 108 global patents, not global talents. Global talents are here, but global patents 108. And They also have proprietary algorithms and methods, 100 plus already, which you can get if you work with them. Okay. Well, looks like I'm convinced. Want to learn more about it? So let's check out what we have here in products and solutions. So here we can see already how this whole thing looks and how it's structured. So you have the quantum computers, so basically the hardware side of things. You have the solutions, which is looking at the not even software side, right? It's already looking at the application side of things, I guess, and the developer tools, which is the software side of things. So in quantum computers, we see Quantinuum systems, system model H1, H2, Helios, and the hardware roadmap, which is something that already we've seen with multiple other companies in the hardware space to put out a roadmap and to show how this whole thing is going to develop. But we start with the one at the very top, which is Quantinuum systems. Leading the charge towards large-scale, fully fault-tolerant quantum computing. By the way, very beautiful image here of probably a rendering of one of their systems. We will probably learn in a second how they actually work. So, yeah, what do we have here? Proven to scale. Our systems are okay, very good. Then we have unparalleled quality and solving complex problems. Yeah, okay. Here we have the different chips, I guess. So system model H1, the first commercial quantum computer to achieve 3 nines fidelity, so 99.9% accuracy. Then we have H2, which is the latest generation quantum computer. And then we have Quantum Helios, which is a hardware as a service offering. Okay, so that's probably the cloud solution that they're offering. So again, very similar to what we saw before. We have let's say the entry-level product, so the H1 in this case, which is probably with a limited number. Then you have the H2, which is the flagship, like maximum amount of what you can get. And then you have the cloud product, which is the easiest to access product of all of those. Okay, here I guess we can see the chip. Yeah, it says system model H2 quantum processor. Let's see if it also explains something about how it works. I don't think so. So it's still very mysterious. Here it says, here's how our ion-trap systems deliver on the potential of quantum computing. So we are talking about ion-trap systems. So basically confining single ions, usually in something like a row, and then manipulating them, for example, with lasers into different states. And this is a very interesting approach as well, because these ions, they're sitting in a vacuum, so they're very nicely separated from everything that can distort them. That's why they are usually working very precisely. That's also what we saw before with the nines and fidelity. And now you can basically use a laser beam to switch the state of such an ion to excite it into a higher electronic state, and then also let it decay. And then you have different types of transitions. Some of them might produce a photon, which you could measure or whatever. And then you can also bring them into vibration state. So the whole chain of ions you can put into a vibration state. And thereby you can couple, for example, the whole chain. So just a very, very, let's say, brief wrap up on how this basically works. So what do we see here? It says proven to scale, unparalleled fidelity, and leading in fault tolerance. So as I said, very high fidelity with large qubit numbers in this case even. Okay. Fixed qubit locations. Okay, that's this chain that I was talking about. And we are the only company who has solved the wiring problem. I'm very excited to figure out what the wiring problem is. But before we do that, let's quickly look at the unparalleled fidelity part. So first, to reach the 3 nines. all-to-all connectivity. So again, you can basically connect every single ion to every single other one, probably via some vibrational states, but I don't know. Here it says something. Oh, it says something about swap gates. So we have to look into this a little bit deeper. Not me guessing around here all the time. And then we have ionic qubits are identical by nature, so eliminating the need to calibrate. That's also very important. So when it comes to, let's say, solid state systems, usually, even though you try to confine a single quantum state, they're usually built out of a whole collection of systems, right? So even if you just look at a chip, it is a system out of millions of atoms, right? And now, if you then try to build a quantum system, let's say a superconducting loop or whatever, none of them will be exactly the same. It's just not possible to build them exactly the same. So that's why you need to calibrate and fine-tune those. And here it says, well, these are ions. So these are really like single atoms, ions. So basically they are all the same. There is no difference, right? Except of course, if you had some isotopes or whatever, but these you can sort out. So here they are really all the same, so you don't need to tune anything. It's already out of the box by nature, all the same. Okay, and then leading in fault tolerance, it says basically first to demonstrate real-time error correction. Okay, lattice surgery, break-even error rates, and beyond break-even error rates. Oh wow, that's interesting. So very precise systems and real-time error correction. That's pretty cool. Then we have this all-to-all connectivity that we saw before for a wider range of exotic and efficient error correction codes. So also possible to use this connectivity to remove even further these errors. And then there's a qubit reuse. Okay. Now, what is the wiring problem? Oh wow, there's a whole post about it. Okay. I have some homework to do after the video. I can already tell you that. And then here it says, start your journey. Oh, interesting. So you can even go to Microsoft Azure Quantum. Okay, Oak Ridge Laboratory. So these are basically all, looks like they're all places, and of course Quantinuum systems, where you can start right away to access a machine of theirs. Oh, that's very cool. And then, of course, you can also buy one if you have the money. I don't. Okay, let's very quickly check out those here. So the solutions and the developer tools, and then learn a little bit more about the company and the research as well. Okay, Quantinuum origin. Strongest encryption. So that looks like now we are in the encryption space. So remember the random number generator that we saw before. So protect critical data, rapidly enhance cyber systems. Okay, lead to the front. Ah yeah, and then we see here again those customers that we saw before. Here it even explains how it works. So you generate this quantum cryptographic seed, which is a seed phrase, so a string out of ones and zeros that are actually random by the nature of quantum. And then, okay, the seed quality is proven using a Bell test. Okay, and then you can protect this, use this to protect your information. Oh, that's cool. And I mean, I like the beauty of this is it's very, let's say, simply explained, even though it's a whole topic in itself. And by the way, if this is interesting to you as a topic, like the cybersecurity side of things, please let me know in the comments down below, because then we can make a video on this specific topic, right? Then we can look a little bit deeper into that. Let's also check out some other solutions they have here. So here it says accelerate computational chemistry using quantum computers. So now we are in the material side of things again. So molecular and material simulations. Okay. Again, we see automotive and aerospace. So we saw already before BMW as a customer. We have pharma, so using this to develop new materials. Materials, basically same topic. Energy, so energy grids are probably very complex, so maybe this is being used for that. Let's see. Oh, modeling carbon capture, okay. So here this is about the CO2 and the carbon capture, okay. That's a material topic as well in a way, I guess. Modeling carbon capture on metal organic frameworks, so yes. And chemicals, okay. So using, okay. So kind of makes sense to use a quantum computer for all of these topics here, because in a way they are all, let's say, except of maybe automotive and aerospace, but pharma is chemistry question, materials is quantum side of things, energy in this case is also a very, let's say, fundamental quantum chemical topic, how to capture CO2, and then chemicals themselves as well. So makes sense to use a quantum computer for things like this, right? Okay, and here it basically explains what you can get when you partner with them, and how such a project would probably look like, right? Okay, and then let's move maybe to the developer tools as well, just to quickly check them out. So there is TCAT, LambEQ, and Kermit. Oh, that's a funny one. I hope I pronounced them correctly and I'm not coming up with jokes that were not intended to be jokes, right? Okay, so they have basically, looks like they have their own system to develop quantum applications on their systems. And yeah, you can learn more about it by clicking on it. So this TCAT seems to be the easy access one, where you basically just build algorithms maybe via drag and drop. But I also see that there's pip install, so you can use Python as well. Let's quickly check. Oh, now I have too many tabs open. See, I'm already getting confused here. So, here. Let's go to the second one. Oh, maybe to Kermit. Oh no. Ah, here we are again. Okay. So let's check out. Okay, this is leading us right away to GitHub, which is, oh, okay, you also have a Python library here, so it's also pip install. Well, shouldn't be surprised. Python is the one to use, right? Is a model for running error mitigation protocols. Okay, so this already goes quite level deeper, right? Before we saw, this is very much on the high level. Okay, how can we use a single qubit and 2 qubit gates to build an algorithm? And this is already down to error mitigation protocols. So how do we actually interact with the different qubits, and how do we make sure that this algorithm can actually be executed on this specific platform? Okay, then we see that there's some research also going on here. So they have research areas marked here, where they probably do active research in hardware, cryptography, chemistry, computational intelligence, AI and machine learning, so quantum AI, quantum information science, physics, so also down to the very physics itself, computer science and mathematics. Here we see some Schrödinger equations. So okay, there's a lot of articles published here. So that's probably a whole research topic in itself. There's a technical blog, which is probably breaking it down in a way that is a bit easier to read. This is also pretty active. We see this is May 12th. This is being recorded end of May, so there is some stuff happening here. Yeah, then we see the publications that we saw before. So yeah, looks like there is a lot of stuff happening here in the research area. And then let's, as a last thing, also quickly take a look at the company. So what is actually Quantinuum and where does it come from? So they say they are pioneering the next area of computing. That's something that we saw already before. We are making the impossible possible. Okay, so to accelerate quantum computing and use its power to positively transform the world. So they want to have a positive impact on the world right away. And here we see the team behind it. So enterprise leadership, scientific leadership, and board of directors. So looks like a proper company already. Then they have various different addresses here. So they're already pretty much all around the globe or all around the blogosphere. And with that, I think we have had a nice initial look at Quantinuum. I hope that was helpful for you. If you liked it, then please give the video a thumbs up. If you have any other company that you would like me to take a look into, write it down in the comments below. And always make sure to stay hydrated. And then see you in the next one. Bye bye.